Okay, 47-second clip of Zuckerberg for the TITV earlier today.
A lot has been written about money and all that. And like I said before, a lot of the numbers specifically have been inaccurate, but it discounts the other key reasons why people are super excited to come work on Meta Superintelligence Labs. And one of the biggest is that you could just have more leverage as a researcher. You have more compute. The best researchers, historically, when I was recruiting people to different parts of the company, people are like, okay, what's my scope going to be? And here, people say, I want the fewest number of people reporting to me and the most GPUs. Having the most compute per researcher is definitely a strategic advantage, not just for doing the work, but for attracting the best people.
A selling point is that you just have all the GPUs you need, and we're just going to let you roll with it. I like that. At a company, when it was termed machine learning, that was the business application of it. That was a big deal for those people at the company. We just want to be left alone. We don't want to be worked into the software development lifecycle like you engineers. Just give us the compute. When they didn't pull up with all the resources, that they left. You need your toys if you're going to be doing this kind of work. I'm excited about making each GPU or each researcher more efficient instead of just throwing total volume at it. But in the hype cycle we're in, that's just not as sexy right now. It's just throwing a lot of money at it. But as a bootstrapped, profit-hungry person, that's what I'm excited about. What else we got? Introducing Renaissance Vocal Percussion Baby.
Really good.
I don't like how his boots and cats sound. That sounds like an adult, and I don't like how it's coming from a baby. Do you guys pick that up? Even his little sounds like an adult voice. Either way, that's really impressive. I don't know how you come up with that idea. What's next? Okay, back to Sam. This is from about a month ago. I agree with what Jensen's been saying about jobs. Betting against humans' ability to want more stuff. Find new ways to play status games. Find new methods for creative expression is always a bad bet. Maybe human money and machine money will be totally different things. Who knows? But we have a lot of main character energy. Yeah, I generally like this idea of like things are going to change. Yeah, some jobs are going to go away. Some are going to come up. And this is how it works. I know that goes against this idea like I am this profession and the world owes me having this profession stick around for a while. And that's a bummer for people who really like that job that they had that is no longer as defensible as before. I feel more at peace when I just accept like, yeah, I'm going to have to evolve and I'm going to work really hard to get whatever skills I have now. And then in a few years, they'll be gone. And then I'm going to evolve again. I'm trying to be committed to the effort of just constantly working hard and evolving. These LLMs have kind of outsourced me and all my syntactical knowledge of code. And good, fine. I don't need to memorize all the syntax and algorithms anymore. I can do other stuff. I think that's kind of the gist of what Sam's saying. Okay, here, what do we got? Higgs field effects. Fire breath, paint splash, inner glow, glowing fish head off. Your head, yeah, gone. What a drop. Glowing, inner light, glowing fish. This is kind of cool. Having an aesthetic or a theme to the edits. That's pretty cool. I've been thinking of ways to make your brand feel like you when we're all using the same models. Maybe it's just doubling down on something like this. I'm the paint splash guy. I'm the glowing fish guy. I'm the slime man. On my thumbnails, I've been doing the dotted grid paper because that's a callback to a lot of my older videos and my love for bullet journaling. So maybe I'm the dot grid guy. As long as you can make anything, maybe you're just different by what you stick to and staying in your lane. Humanoid Hub, the world's first humanoid robot capable of swapping out its own battery. Okay, I've actually seen this before. This only got 81K views on this one, but this video has been making the rounds. I wish its head was facing the other way. Something just doesn't sit well that it's not looking at it. I don't know why. Makes me uncomfortable. Yeah, that's pretty sick. Wow. That's cool. I think Sam said this, that we haven't had our humanoid robot moment consumer facing collectively. That's going to be a big jump. I still talk to people like my parents and grandma are kind of like, it's a toy. But once the robot comes in your house and everyone has a robot, it's going to be different. Here's the veggies. This is what I was really excited to get to. I found this through a newsletter called Bites, a front-end newsletter, and it's called Typechecker Zoo. And the guy says it's a pet project I've been working on for a while. Minimal implementations of the most successful static type systems of the last 50 years. I had no idea this was going on for that long. Toy implementations of programming languages and the core type checking algorithms. I didn't really understand type systems ever until I worked in TypeScript a little bit and Java a little bit. Like I knew it was a thing and I had to deal with it, but like under the hood, I didn't really understand there was math and like deep logic behind it. So I was poking around, and before I even went there, I was like, who made this? This is from Stephen Deal. Fun little weekend project. My first thought was, we have very different weekend projects. Me and Stephen. I think he's a real one. He says he's a software engineer. What kind of crazy software engineer is he? Co-founder, a CTO, principal engineer, and software engineer at Anaconda, and more. So he's a real software engineer. Sometimes your title is software engineer, but it feels like you're a mechanic. Sometimes you're a software engineer and it feels like you're a mathematician. And this guy feels like the latter to me. So I was excited to try to see if I could understand what the heck is going on. Apparently there were 4 main algorithms. Actually, I don't know what this part is. This part might be broken. Okay. So apparently there's 4 algorithms that do these kinds of type checking. And he re-implemented it in Rust, I think. So I pulled it down. I had Claude summarize it for me. That's my app. Here we go. I said summarize it like I'm a 5th grader, like I'm 5. Okay. Let's see. Explain like 5. Here's what we got. I told it to use Mermaid so I can just visualize it. And it's kind of nice. It kind of calmed me down about what the heck was going on. But it's talking about how type checking makes sure things match, using an example from toys. Then it talks about the different algorithms and explains how they're a little different. Like this one's saying, here's how you do the types. And this one's saying, here's a different way to check a specific type. And this one's saying, a toy that makes toys that makes other toys. And that's pretty cool. The master builder. That's what this one does. So that kind of makes sense to me as a 5-year-old. But then I was like, okay, I think I get that. Let me bump up to junior engineering level. So I said, talk to me nice like I'm a junior. And here's where we're going to pick up. Type systems are like the immune system of programming languages. They catch errors before they can cause damage. That's pretty good. Understanding how they work makes you a better developer regardless of what language you use. And this repo is like a playground. That makes sense to me. So this is, in his own words, what type checking is all about. Let's boot it up. Let's boot it up for fun. I had it running a second ago. Serve docs. Okay. Here we go. This is the page that actually kind of made it make sense to me. What is a type system? Why would we build one? The frontiers. A deep insight has been unfolding since the late 70s. A revelation that 3 immense, seemingly distinct realms of human thought are echoes of a single deeper reality. I feel like I'm reading a storybook right now. I feel like this is the start of some epic space odyssey. This computational trinitarism reveals a profound interplay between different disciplines: computation, formal logic, category theory. Think of it as a 3-way harmony between space, logic, and computation. School! These are not merely analogous. They are 3 perspectives on one underlying phenomenon. The key to this unification is a powerful act of abstraction. While mathematics seem to be about many different things like sets and shapes, it fundamentally relies on the notion of a map. Set theory is about functions. Topology is about continuous maps. Algebra is about homomorphisms. And logic is about implication. Wow, that's deep, and I understand half of that, but let's assume he's right and keep going. With the right framework, we can abstract away the specific details. What matters are not the objects themselves, but the maps between them. When you refine a concept in this universal language, something incredible happens. You can translate it into any other category. A group defined in the category of sets is just a normal group, but translate that same definition to the category of topological spaces and you get a topological group. In the category of manifolds, you get a Lie group. This is the Rosetta Stone for the foundation of abstraction itself. He lost me again in the last two, but that's okay. We're going to keep going. This is why this is an exciting time in software. These concepts elevate types from simple data labels into a rich language for encoding deep truths about a program's behavior. These are no longer just academic curiosities. They are architectural principles for the next generation of powerful and provably correct software. Ooh, this grand unification is an extension of the famous Curry-Howard correspondence, which revealed a stunning duality. A type is a logical proposition, and a program is a constructive proof of that proposition. Trinitarianism expands this into a threefold revelation. I'm not going to get into it, but he's all leading to something. I can tell he's leading to something. I pray that when he gets to it, it can make sense to me. Let's keep going. The ultimate ambition this enables is program synthesis. The programmer's role shifts from mechanic to architect. They specify what by writing a rich descriptive type or a theorem, and the system discovers the how by searching for a valid proof, which is the program itself. These frontiers are critical in the age of AI-generated code. As we ask AI with generating vast software systems, the central challenge becomes one of trust. How do we know the code is correct? The answer is to demand more from the AI. We require it to produce not just code, but code whose very type is a formal proof of its correctness. The type checker then becomes our ultimate infallible arbiter of truth. This transforms programming from a manual craft into a discipline of rigorous specification, allowing us to build software whose correctness is not just hoped for, but mathematically assured. This is the awesome power of modern type systems, the journey from preventing simple errors to proving deep truths, turning the age of programming into a direct collaboration with logic itself. Are you kidding me? And that's why type systems are awesome, and hopefully you've come to see how much fun they can be. Holy moly, if you stuck around for this, I hope you're seeing the payoff here. There are so many good lines here. It gets more understandable at the end. If I were to summarize this in my little peanut brain, I would say type systems can help us go from just making something work to making it work reliably, provably, mathematically, theoretically, by giving an AI system the constraints of aligning by types. We can create the logic, and then the AI system will figure out the proof to make it true. So we specify, in his words, what we as programmers say to do. The AI figures out how to do it, and the way it does that is by having a robust type system. And that's where most of this text was about. What is a type system? How is it created? What can we do with it? How do we unify the different areas, which were computation, formal logic, and category theory, to create it? I'm kind of there. Are you guys kind of here? I wish I had someone with me to bounce this off of a little bit. Story time, real quick. In college, I lived with two PhDs in math. They were on their PhD track. I didn't understand anything they were saying, but just being around them, seeing how their brains worked, looking at their homework a little bit, seeing how they worked through problems differently, and talked about just being around that kind of raw intellectual horsepower made me better. And I don't understand anything they said. I don't remember it, but just being around it through osmosis, I think, made me a more capable engineer. And that's how I feel reading stuff like this. It's cool to just jump right in and open up the math book that you don't understand, or read this kind of a paper that's way over your head without trying to go step by step and see if you get everything. It's just cool to try to see and get in the head of someone who's really deeply understanding and think about this stuff. Man, this is exciting. The first time I saw this website, I got emotional. just got emotional that I could just pull up this website from some smart dude who made it on the weekend, uploaded it for free and showed me the code. Then I could ask AI to read the code and spoon feed it to me like I'm a 5-year-old so I can kind of understand it. This is all available for free, and this is how I get to spend my time. There was a period, many periods in the world where this was unthinkable, where science was suspect or ostracized. The pursuit of truth and knowledge and building systems at an architecture level was not something that someone in their teens, 20s, and 30s could think about doing, let alone doing it for free with a Wi-Fi connection. I know a lot of AI and what's happening is transforming things and making people, myself included, feel a little uncomfortable, but also the boom and intellectual advancements in our systems and just what we can do and access as individuals is pretty amazing. And on balance, I feel super grateful to be alive during this time. What a time to be alive, as the great Future and Drake said. With that, thank you for watching. Subscribe. I'll see you in the next one. Bye.